Hey, Jared.
Hey,
How's it going tonight?
all right. How you doing?
Not too bad. Not too bad.
Nice.
Whoops. So it looks like we got the test review this week, huh?
Yeah, a little different this week.
Yeah, absolutely. Sorry, I got my giant face here. I fell off my pedestal. There we go. How's your week going for you?
Oh, all right. Just another Tuesday.
Yeah, I hear you. You haven't heard from any of the other guys.
No,
Have you?
I haven't got emails or anything like that.
Yeah, neither have I.
So,
They should be joining us shortly.
yeah. Get on to. Okay, I'm not sure. I'm not sure if you got this, but 9 minutes ago, it looks like Zachary sent a message. Hey guys, sorry this is late, but I can't make it tonight. I'm cramming for a test in my other class. Haha, sorry.
Oh, all right.
Yeah. So I don't know if the other Jared's gonna make it, but
Yeah, I don't either. Jared and Austin. Looks like.
mhm.
Well, we'll give it a minute or two and
Yeah,
see if they're coming along.
yeah. Have you taken the exam yet? I guess it's open now.
Yeah, no, I haven't.
Yeah.
I just finished up doing the review, so I
Mhm.
wasn't sure. I mean, I was a little surprised that she gave us 4 hours to do it. I hope it doesn't take
Yeah,
4 hours.
yeah. I know it made me a little nervous. It's like, whoa.
I was thinking, what is this? Does they have 300 questions?
Yeah, serious. Oh, but also the last homework lesson we had. Did you do all right on that?
Yeah, I did okay, I think.
Okay. That I must have mixed something up because I got, they had they give you a sample amount of data and then you do all the equations with it.
Yeah.
I got one right and then the last two I were all wrong. So I'm looking back, trying to
Oh,
figure out
really?
like what I did wrong and
Huh.
you
Let
know.
me see. That was the last the homework quiz from last week.
Yeah. Yeah.
Let's see. Is it up? Can we access it? Let's see.
Yeah, it was lesson 7.
Yeah.
Because like when I was doing like the equations, I was like, oh, I'm getting this. Like it feels good. I know how to do this on paper. I don't have to
Yeah.
use the Excel stuff, but apparently not.
Let's see. I have it open. Do you have it open and we can go over
Yeah,
the questions? Yeah.
yeah. So I got 1 and 2 correct.
Okay.
Uh, uh, 3 and 4 I did not.
Okay. So 3, I had 0.041 as the answer.
Okay, I had 0.013. Let me see if I can find the notes I went over here with. So this was the test.
Yeah,
You
the
want-
LSAT. Yeah.
Yeah. You want to say it like 8:15? We just go ahead.
Yeah, sure.
Okay. I don't want to just be selfish and personal tutor time for me.
Sure. No problem.
Okay. But yeah, let's see. Okay, here we go. So let's see. What is the probability that the mean score for 5 randomly selected people who took the LSAT would be above 157 and your answer to 3 years? So
Okay, so what I did is I put it in my little spreadsheet thing.
mhm.
Let me see. Let me open it up here. So I have a little spreadsheet where I plug in the mean. And what's the mean? The mean is 150.
The mean, yes, 150.
And 157 is what we wanted to
Yeah,
find. Is there?
above 157.
Okay, so we wanted above 157. And what's the standard deviation?
9.
9. And the sample size was 15.
So that's what I'm looking at now. What is the probability that the mean score for 5 randomly selected people? So that would be
Okay.
be the sample, right?
Yeah, the sample size is 5.
Okay.
So then I came up with a z-score of 1.739.
0.17. Okay.
So then I put that in the probability applet. So if you type in 1.739 and what's it looking for? It wants sorry.
That's all right.
So above 157. So we're looking for the probability on the applet.
Right.
Above 1.739. And the area is 0.0410. And so rounding that to 3 was 0.41.
Okay, so the z score was 1.739. Is that right?
Yeah.
Okay. And then it was 0.0410.
Yeah.
Okay.
So you want to, when you plug it into the applet, you want to plug the z-score in and then choose the blue out the top
right
piece there because it's above 157.
Yeah. Maybe that's what I did. Maybe for the rest of these, maybe I did the z-score and was like, oh, plugged it in. What's the area? Boom, I'm done. Maybe that's what I did for the rest of these then.
Oh, maybe.
Yeah.
You want to do the other one, the second one?
Yeah. So the second one I remember doing, and it made the z-score like over 4, and so that didn't make any sense to me. But I did it a few times, and it kept coming up the same thing. So I put 0.001 just because that was the only thing I could plug in. But
Okay. So let's see. What I did is, let me put it in my little deal here. So now the sample size is 10. That's the only difference, right? Is sample size is now 10.
So let's see.
So the z-score I got is 2.46.
2.46. Huh. So let's see. So which Z-score, I know you're using the spreadsheet, but for my, I work better with this, like, what's the formula
What
exactly?
the formula?
Yeah. So are you using the, where it's just the standard deviation on the bottom?
No,
Or-
that one is the standard deviation. Oh, let's see. The formula, hold on a sec here. I got it up. So the formula for that is
It's the standard deviation
it's
over the
over
sample
the standard deviation over the square root of the sample size.
Okay. Oh, all right. So, because that's the z-score of the sample, right? That's
Right, right.
and the one without it is the z-score of, I don't know, the population, I guess, or the bigger one.
Yeah.
Yeah. Okay. I must have just got those two confused. I must have been using the wrong ones at the wrong time. So
Well, it's easy to do. A lot of these formulas are real similar.
yeah, that is for sure. So I guess I just got to keep watch over those.
Yeah. Well, looks like maybe the Jared and Austin aren't joining us either.
Maybe it is just us.
Okay. Well, should we start maybe?
I suppose so.
Now it looks.
Yeah.
Or did you have any more questions on the quiz?
No, it's okay. I'm sure once we go through even this review, it probably help me clear
Okay.
out what it is.
Okay.
Let me get back to them.
Well, let me get back here to the assignment.
Okay.
So I guess we just need to open up the preparation quiz, and it seems like it's the same answers from the. Do you want to go over the questions first, or do you want to just open up the quiz?
Oh, it's the quiz is the same on.
Yeah, I think so.
Oh, okay.
You know what? Hold on a second. Let me see what. Yeah. Well, let's go over the assignment, and then we can answer any questions. Does that seem all right to you, or do you want to?
Yeah, no, that's fine.
Okay.
So lesson 8, group meeting.
Yeah.
Okay.
So reviewing the questions in the review, the name of the important statistical result that guarantees that the sampling distribution of the sample mean X bar will be normal if the sample size is large. I think that's the law of large numbers. Is that right? I get those two mixed up.
I know they're very similar. I
Yeah.
thought it was the central limit theorem.
Okay.
Yeah.
We maybe better look that one up.
Yeah. So let's see. Oh, show summaries. Here we go.
Okay, so the large. Oh, you're right. Right.
Okay. So yeah.
Yeah, the law of large. Okay, I had it backwards.
Yeah, central limit. It's like the bigger it gets, the more towards the center it is, more normal distribution it is.
Yep. And the other one is the law of the large numbers, right? The law of large
Yeah.
numbers.
Has to do with the mean, sample mean, and the population mean.
Okay. All right.
Right.
All right. So that's 1 and 2.
Yeah. All right. 3. Which of the following variables is or are categorical? The number of animals in the local zoo, a randomly selected brand of toothpaste at the convenience store, age and years of a randomly selected vehicle in a parking lot. I'm pretty sure it's 2 is categorical.
Yeah. That's what I had.
Okay. Because
the other one is what it's is it statistical?
quantitative.
Quantitative. That's right.
Yeah, which is numbers. So
Yep.
Whatever you can number is quantitative. I think how it is.
Okay. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of these two numbers is a parameter and which is a statistic? So the parameter is the bigger number, the number that represents the larger group. So that's the mean IQ score in the U.S., which is 100. And the statistic is the mean of the sample. And so that's the randomly selected student score, which is 112. Does that sound right? Do I have that one backwards too?
I think that's right. Yeah.
Okay.
All right. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample would we collect to gauge the residents' responses to a proposed increase in property taxes? Macro. Okay. One neighborhood has very low property values. Property taxes. Oh, okay. I would almost say a cluster sample would be best to use.
You know, that's what I started with, and then I changed it to stratified, but I don't really know what the real answer should be.
Yeah.
The only thing that throws me off about the cluster sample is the cluster sample involves surveying everyone in a certain certain group. I don't know how you would survey everybody, but maybe you would.
Yeah.
I don't know. I don't. I have no idea what the answer is.
This is kind of almost up to opinion, really. I mean,
it could be. I mean, I would think you'd be able to use this a few different ways.
Yeah.
I was wondering if it's a stratified because of the different levels of property values in each of the neighborhoods, but I don't know. I could easily go with cluster sample too.
Mm-hmm.
See, the neighborhood thing is what makes me think it's
larger.
That it's maybe a cluster sample too.
Yeah. It's giving us 2, like one is higher property, the other is lower, so it's giving us almost categories.
Yep. And that would be more closer to stratified, but
yeah,
if we're talking about distinct neighborhoods,
yeah,
then that would be more about the cluster.
Oh, macro. Well, I could choose one and you could choose the other.
I guess. Well, let's move on to that one and we'll just kind of star that one or something.
Yeah.
All right. So the 6 is when designed experiments are conducted in public school systems, Researchers typically choose a particular district and randomly select teachers of, say, the 4th grade students in that district. The experiment is then conducting using all of the students in the selected classes. Which type of sampling scheme is implemented? See, that to me sounds like a cluster sample.
Yeah.
Because you're choosing a certain group and picking everybody in it.
Yeah. Yeah. Yeah, that sounds good to me. Because I mean, how do they define cluster sample in the summaries here? Let's see. Cluster sample is all items in one or more randomly selected clusters or blocks.
Yeah, and then a stratified sample is divides data into similar groups, and a simple random sample is taken
from each group. Huh. So that makes it from those definitions, it makes me think that the neighborhood problem is a stratified. Like,
yeah.
You're dividing it into similar, property taxes or whatever.
Right. Well, that's what I was thinking. I initially had it just like you said as a cluster, but then after reading the second example and the definition, I changed it to a stratified.
Yeah. But this class one is definitely a cluster.
I think so. And what makes me think that is when the phrase all the students in the selected classes.
Yep. Yep, that's it. All right. So 7, at a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? That to me sounds like a simple random sample.
Yeah, I agree.
All right.
Number 8 is a special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? That's feels like maybe a stratified sample.
Mm-hmm. Oh, there's Jared.
There's what?
Guys.
Hey.
Oh, hey, no worries.
Just remembered. Now I gotta get plugged in before my computer screams at me and then gives up the ghost.
Is Austin joining us tonight?
Yeah, well, he came over and he asked me if he had a question or something, and it reminded me, oh crap, we have a meeting on that. So he just ran home and he should be on in like maybe 30 seconds or so, I don't know.
All right.
So what's been going on?
We're just going over the review sheet, review questions.
Okay. Cool.
You guys a minute to get on.
Okay. Sorry about that. Just got back from an exam.
No worries. We're up to question 8, so we can back up and go through those
fine.
real quick.
Okay. We'll just continue from wherever you're at.
Okay, maybe there was one we weren't sure about. Maybe we can get you guys' opinion on it.
Yeah.
It's number 5. The question is: Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes?
Where is this?
Oh, sorry, it's the review sheet. What's it called?
Yeah,
Are you, is that number 5?
I think that's number 5, yeah.
yeah.
Yeah, you just read number 5, right?
Yeah.
Okay.
Did you find it?
Yeah, I'm rereading the question.
Okay.
I mean, I can hear the question, but I don't process it until I read it.
Sure, no problem.
It's pretty wordy. So.
Yeah.
So-
So,
Um,
I'm sorry, go ahead.
So what it's asking for is what type of sample selection
Right.
would you do? And we had a question similar to this about like populations of like apartments it talked about,
Yeah.
and like college students versus like other people and stuff like that.
Right. I remember that one.
And, yeah, and so the answer that that one had was that it was like you selected a random few from each population, and that gave you a proportionate sample of the whole population.
Right.
Okay.
So that was So initially, we Jared and I both thought it was a cluster sample, and then we changed it from a cluster to a stratified sample, which sounds like maybe is more closer to what you're describing there, Austin.
Mm-hmm.
What do you think?
Yeah, I'd agree.
Okay.
Isn't there a cluster sample where you just like go and sample everything from the one group?
Yep.
Yeah.
So it doesn't.
Yeah. So
And if you look at number 6, it mentions conducting the experiment on all of the students in certain selected classes, which makes me lean toward a cluster sample on that one, but a stratified on the other one.
right.
Okay. So I think we're all in agreement on that.
Mm-hmm.
Right.
All right. So do you want to go over in 6 and 7, or do you want to move on to 9, which is where we were at?
Let's do 9.
So 9 is calculate the descriptive statistics of the amount spent in Crossroads purchases. So we have to open the data file Crossroads purchases. And then we're trying to calculate the mean, the standard deviation, and the 5-number summary of the data.
Yeah, I'm opening it.
Okay.
I'll throw it in the calculator.
Okay. So I already calculated, so maybe I can compare mine answers to yours.
Good. Yeah, so we'll just take all this. And is that what yours looks like?
Yeah. Pretty much the, let's see, I got a mean of 4.77, a standard
Sorry, what?
deviation. Oh, sorry, go ahead.
4.7?
Yeah.
Okay.
Standard deviation of 1.91.
Uh-huh.
The min was 0.84.
Yeah, I think we're good.
Q1, okay. So I did mine in SPSS, so it looks like, they came up the same one.
So they want the mean, the standard deviation, and 5-number summary. Oh, so
Yep.
that's easy. That's just plugging it in.
Okay.
Yeah.
Create a histogram representing the amount spent in Crossroads. Can we just do that?
Yeah.
That's this thing right here.
Yeah.
Okay. Jessica Murr and her research team measured the body temperatures of a sample of diving elephants system. We had a question just like this in the reading.
Yeah.
A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. Researchers estimated that typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals, and then the seal's body temperature at the start of the dive was calculated to be these numbers. Complete the following table. Oh dear.
So we really, for starters, we only need to calculate A for question 1. Or question 11, sorry.
Yeah. Let's see. Standard. So deviation from the mean.
So we have to figure out the mean first.
So yeah, we just find out the mean. We add all these numbers up, divided by 4, and subtract it from each number.
Trigger the score tab.
So I got a mean of 38.075. That sound right?
Yep. That's what I got.
Okay.
$38.75. So A would be negative 0.165.
Yep.
And so you do the same exact thing, you just square it.
Oh no! No! Sorry.
You just multiply it by 0.05. Or if you're just going to square, never mind. Not. Or,
Is there any answer key for this one?
No, there's not. But the quiz is entering the answers. I wonder if we ought to open up the quiz and see if we can be entering these values as we go.
What quiz?
Well,
there's a quiz on the
there's a
island.
quiz on the group meeting.
Oh, what?
Yeah.
But the quiz is the so what it says is compare your answers from the individual preparation assignment, then input the answers into the group meeting quiz.
Oh.
So the quiz is the homework.
Oh, wow.
So maybe I'll open it up the quiz and see what it looks like. Should I do that?
I just opened it up and it's word for word everything. So.
Oh goodness. Okay.
Yeah.
Oh boy. I'm gonna do it a little bit.
Okay, well,
Well, maybe we can open up the quiz and we can answer it as we're going along.
I'm
Yeah.
gonna, yeah.
Alright, so I can go back and do.
Oh yeah, this is nice. It actually gives us answers to
Oh wow!
Yeah.
Actually, I like
Really
that.
nice.
Let's just do that.
So 5 we said stratified. 6 we said cluster.
So we can start back at 3 and just go through these if you guys want real quick.
Yeah, that'd be nice. Sorry.
No worries. Okay, so 3. What did we have here? Which of the following variables is categorical? The number of animals in the zoo, a randomly selected brand of toothpaste at the convenience store, age and years. And we had a randomly selected brand of toothpaste
Yep.
is the one categorical item.
Sounds good.
That's what I had.
Okay. And the mean IQ test, 100 is the parameter, and 112 is the statistic. Does that sound right to you guys?
Hmm. Sure.
Okay.
Well,
Just
don't
take
even
it
remember
based
those
off a
words.
sample. Where
I went back
the
to the recap. And let me read you what the recap says on lesson 3. A parameter is a true but usually unknown number that describes a population. A statistic is an estimate of parameter obtained from a sample.
Yeah. That's how I interpreted it.
Okay.
Parameters, population, statistic is sample.
Yeah.
P's go with P's, S with S.
Oh, there you go.
I like it.
Oh, okay. I just read the question. Yeah, it makes sense. Okay. Yeah, I thought for some reason I thought you were saying that the mean was 100 that they got, and then this 112 was like some sample they got.
Oh, yeah, okay. Yeah,
I was like, what? Yeah, at a school fundraiser, the name of every sorry, number 7. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? So every
Simple.
person. Yeah.
Simple random. Is that what you guys put?
for 7? Yeah.
Yeah.
8 is the special interest group. We had a stratified sample for that one.
Stratified?
Yeah, because there's 2 different groups and they're taking simple random samples of each group.
Let's registered Democrats and select a sample of 100 people and then take it. Okay. Yeah, I guess so. Yeah, that's more, because I was thinking it was systematic, but it's more stratified because of the separation in groups. Makes more sense.
Yeah.
They didn't really have like a system. They just randomly did it.
Right. The systematic would be, every 10th or every 20th or whatever.
Yeah.
Okay, so.
So 9 we said was 38.075.
9. The mean. Well, it's on 9. It's looking for the mean. That's 4 points. Oh, I only had it rounded to 2.
Let's see.
What do you have on yours?
0.771.
Okay.
But what do you guys have?
0.771.
Did I grab the wrong? Maybe I'm thinking of the Crossroads one. No, it is the Crossroads one.
Yeah, that's the Crossroads one.
Oh no, I was Sorry, that's the mean for the body temperature thing. 4 point. I'm getting all mixed up. Yeah, because the next one asks for like the mean and stuff.
Mhm.
Yeah.
So 9 is 4.771.
Yep.
And 10 is 1.912.
Okay.
1.912.
Yeah.
One. I created a histogram. Ooh, this is going to be the hardest question.
I know I did. You guys have to open Excel. You guys can live vicariously through me. That's fine. Okay, so this is the okay. So I still have those numbers. So negative 0.165 is A.
Do we need the negative in there?
Yeah, I think
Okay.
so.
I don't think it's a deviation. Or a z-score, I mean. I think it's just deviation.
Yeah.
Well,
What is the value of the number that goes in the position marked with an A? Well, that's the value.
Because it's the deviation from the mean. It says x minus bar x, and bar x is the
it's the mean.
it's the yeah. Well, yeah.
So mean is 38, so that's negative 38. Okay, yeah. I'm okay with putting a negative.
Okay, so we have negative 0.165.
Yes. And then 0.681. So yeah. Oh wait, 0.681.
Yep.
Oh, how is this going to be?
0.681.
Yeah.
Yeah.
0.681. That's what I got on my Excel at least.
What quantity is equal to the sum of the numbers in the square deviations column? I mean the variance?
Is that the standard deviation or is that the variance?
The variance, the standard deviation is the variance, square root of the variance, isn't it?
Yeah. So the squared deviations, or the sum of all of that is the variance. So that's the answer to 14. We okay with that?
So the variant. Okay, so I know you just said this, but the variance is the squared deviation, and the standard deviation is the square root of that. Is that what you just said, or?
Yeah.
So the quantity is equal. What quantity is equal to the sum? So the number that I got for the sum of the square deviations is 1.534.
Yep, the same.
And I don't know what that number is really equal to. Wait, let me go to my other.
Well, actually, I think I keyed it in here.
Is that equal to the variance?
What was the number one more time?
So the sum of these squared numbers is the variance, and then you square root them, and you get the standard deviation. So the standard deviation should be 1.239. So I did what they did. Here's my data. I redid it, so I made sure it was right. And then x minus the mean, and then the x minus the mean squared. And then this is the sum of all these squared values, and I took the square root of that value. And I got the standard deviation.
Yeah, so it's equal to the variance, though.
What?
Yeah, so the answer is going to be the variance, right?
Oh, yeah. Number 14, yeah, it's the variance.
Yeah.
Sorry, I thought you were still talking about 15. I was like,
So,
Oh, no.
yeah, so I just did 15. 1.239.
Okay. Oh, sorry, go ahead.
239.
Yeah, 1.239.
Yeah. No, and 16 is false.
Yeah, that's what I think.
Yeah.
In the same study, the researchers placed the results were. It gives the answers. Does it really just do? Oh, okay. I thought it was the same exact thing. Well, let's go back and check. Which location resulted in the most consistent temperature measurements from one seal to the other? So that would be the smallest standard deviation, which is
Extradural.
Yep.
I can define standard deviation in my own words.
Standard deviation is the distance from the mean, the average distance from the mean.
Yep.
Let's see. That's that one theory that talks about the curve, right?
What?
Well, I defined the standard deviation in my own words, but it's not right. True.
All right, so the third quartile is 8. That number 19?
That's what I thought.
Yep.
And the percentage of the data that lies between 4 and 8, is that 50%?
68%?
Correct. No, it is 50.
Is it the 68?
No, that's not this. This is the quartiles.
Yeah, that's distribution. Sorry.
No problem.
Yeah.
So there's 25% below and 25% above.
Yeah.
Yep.
Okay.
Big long one. Observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 ppm. And values outside of the range are unusual. We will assume 1.59 ppm is the value of U minus 2 times the standard deviation, and U plus 2 times the standard deviation is 2.25. is reasonable to assume the measured nitrate concentration is normally distributed. Use the information
Are
answer
they just
21
saying that the
and
z-score
20.
of 2 would lead to 2.52? Is that what they're saying?
So they're saying so on the normal distribution curve, if you guys can see my screen, it curves down, and at 2 over here on the far side, it's going to be the 1.592 and negative 2, or I guess it would be positive 2, it's going to be 2.52, if that makes sense.
Yeah.
So the mean is going to be like the middle of those two.
Yeah.
Oh, I see what they're saying. This number is this,
Yeah.
and then this number is this 2.52. Oh, so this is 2 standard deviations below
Correct.
me and 2
Yeah.
above.
Yeah. Negative 2
Okay.
standard deviations.
So we just need to find the middle of that, right?
Yeah, so estimate the mean. Oh, okay.
Yeah. So I have 2.055. How many? 3 decimal places?
Did you just minus them and then divide by 2? Or
Yeah.
yeah.
But I also added them together and divided them by 2 and got the same number.
Oh,
I think. 2.52 plus 1.59
what?
divided by 2.
That's not right.
2.055.
same here.
Oh, wait a minute. So you're looking at 2.52 minus 9. That would be divided by 2 and then plus
2.055?
Yep,
You guys okay with that?
got it. With the standard deviation of the measured nitrate concentration in Rexford's drinking water. Oh, how it is, yeah.
Okay, well that should be easy enough. Now we just got to subtract 2.055 from.
You know what? If you actually go down to 23, I think it gives you the next numbers for 1 standard deviation away,
Oh, yeah, you're right, it does.
which is like the standard deviation if you subtract that.
Yeah. So this is 2 standard deviations. We just need to
I
contract the 2 numbers divided by 4.
D for the answers, A or D. And it's gonna be D, I mean, because it's in between 1.5, and the upper limit has to be in between our mean and our 2.5.
So I have a standard deviation of 2.33. I'm sorry, 0.233. Thank you.
Yeah.
Is
And Austin's right. Yeah, I plugged in the standard deviation and got those numbers.
So 0.232.
33.
2333. We're
23.
rounding it to 3. Yeah.
Okay.
So then 23 would be 1.822 and 2.288. No, wait.
Yeah, 1.822 and 2.288.
Okay. Thank you.
Okay, what is the value of the mean of a standard normal distribution?
I had to look this one up.
It's just the mean.
Standard deviation of a standard normal distribution is 1.
What is the value of the mean?
Oh, the mean is 0.
Yeah, that's what.
Sorry, I was looking at
The next
25.
question. Yeah.
Wait, what is the value of the mean of a standard normal distribution? Value is 0?
Yeah.
The mean is 0.
Can someone explain that? I don't really remember that.
Yeah, I don't really understand it, but I'll read it off of the summary here. Let me look here. Sorry if I can find it here. I know I had it right here. Sorry, guys.
I have it if you want me to read it.
Yeah, that'd be great. Thanks.
A standard normal distribution has a mean of 0 and a standard deviation of 1. The 68, 95, 99.7% rule states that when data are normally distributed, approximately 60% of the data will lie within 1 standard deviation from the mean, 95 within 2, and approximately 99.7 within 3 standard deviations from the mean. So, from what I understand, it's used as like almost like a skeleton. I don't know. This is how I think of it.
Yeah, it's pretty much referring to the z-scores, it sounds like. When it says value, it's saying like the z-score of the mean
Yeah, that totally.
and the
How did they just do
z-score of the of a standard deviation. That's pretty much what the two questions are saying.
Right. Yeah, that makes sense.
That's oddly worded. The admissions committees for most masters of businesses. Oh, everyone got 25 right? Number 1? Or,
Yeah,
so
it's
24
1.
is 0 and 25 is 1.
Yeah.
Okay. So 26, the admissions committees for most
Wait.
masters.
Oh, yeah, I'm sorry. Go ahead.
Okay. Programs require the graduate management as part of the application for new students. It has been shown that the scores of the GMAT are normally distributed with a mean of that and a standard deviation of that. The minimum GMAT score required is 500, but it is rare for students with scores less than 600 to be admitted. Interesting. So what is the probability that a randomly selected students will score above this and above the mean? So that would be 50%? No. You
Yeah,
have to calculate this, don't we?
so it'd be 0.5.
Oh, because it is normally distributed. Okay. And then score below 600, we do have to calculate that, right?
Yeah.
Does someone want to read off the value, or so 600?
Sure.
The mean?
I'll read it. So the mean is 542.3. Standard deviation is 120.54. And the x value is 600.
Yeah. So x value 600, mean 542.3, standard 120.54.
Yep.
Okay, so 0.479 is the z-score, and I'll plug that into this little applet. What do they call it, applet?
I don't know. That's a good question.
It's like a baby app, so they call it an applet.
Yeah, it's a very small app. Very small rocks.
And then they want to know if the odds of scoring above it.
Below.
Below 0.684.
That's what I got.
Yep, that's what I got too.
Same here.
And then score above, that would just be on the other side. Yep.
31.6.
You have 0.316?
Yep.
Okay.
The 10th percentile.
Yeah, so this one was a little tricky at first.
They want to know, oh, that the score, what that is. So just
Yep. So you have to reverse engineer that a little bit.
They probably know.
I have the equation up.
Okay.
You guys want to see it? Okay, so let me screen
I
share.
got 387.768.
Do you have it too?
Yeah.
Okay, yeah, you had the value back, the backwards value. Okay, cool.
What did you have, Jared?
Same thing, 387.
387?
Yeah, what do they want, or how do they want it formatted? To nearest whole number?
I had 344. What am I doing
Well,
wrong
it's
here?
actually 388.
Maybe I... Okay, so you plugged in under the area, 0.1 in the applet, right?
Yeah.
And you clicked on the left side.
And I think
0.1282.
Is 542.3, standard of 120.54.
Oh. Yeah, you're right. I just must have keyed a number in wrong. 388?
Yep.
yeah. And then you can actually do with the next one. I think all you have to do is just take off the negative on your numbers, Jared.
Yeah.
So you take off the.
Oh. Because it's up there. The
You have,
the 90th percentile is.
No, that's
Yeah, it's the same exact.
above the 90th percentile, or is it?
it's, yeah,
Or it just doesn't matter even.
it's
You
the
can
90th percentile. So you want everything under the 90%.
Yeah.
Yep.
Did you get 697?
Yeah, 697.
I mean, you can. It's all about the z-score, really. You don't even have to highlight any of it. That
Yep.
just helps you to know that's 90.
Yep.
Yeah, 697. Okay.
Yeah.
Ooh.
Quartile.
Sorry, I got left behind. What was 26 and 28 again?
26 is 0.5
Okay.
because that's just half. So probability is 50% that people will score above, 50% that people will score below.
Oh, okay. Oh, because it's the mean, right? Okay. Right. Yeah.
Right.
Okay. And then 28 was that the same as 27, right?
No, 28 is 27 or 1 minus 27. So it's 0.316. Does that make sense?
And then 27 was negative 0.316, right?
No, 27 is 0.684,
Oh, 684.
and 28 is 0.316. Is that what you guys had, Austin?
Yeah, 0.684 and then 0.316.
Yeah.
Okay.
So those two numbers add up to 1.
Add it to the 1. Okay. All right. Thanks.
Did you get 29 and 30?
Yeah, I got those.
Okay.
And then 31. You guys calculated out yet?
It's,
461.
let's see. Yeah, that's what
Yep,
I got.
That's what I had too.
I got 32 as well. So that's 624.
Yep, that's what I had.
$33. I mean, it gives you a sample size and stuff, but then it asks you what is the mean of the distribution of sample mean scores. That's just the mean, right?
Right.
Doesn't change. So that's a 542.3.
Yep, 542.3.
And it lands to the 1 decimal place, so that's good. And then
The standard deviation will be, oh, that one we have to calculate.
we 31.123.
3. Yep.
Is that what everyone else got?
Yep, 31.123.
Yeah.
Yes.
31.123. This is the stuff that kind of confuses me because I don't see any application for this portion of it. I just figure out how to. I just figured out how to calculate it. So.
Yeah.
Yeah.
So, same stuff, but they want to know if probability of being greater than 600.
And then this is the stuff that really took me a while to figure out. 600.
Yeah.
I got 1.85. 4.
What?
I got 0.0319.
Yeah, same here.
0.0319. For 600. Yeah, this is the part where I like.
Okay.
Now, this is the one where we like did the crazy math to like, okay, we got the x value, we got the mean standard, but now we have a sample size. So now we have a new standard deviation. And instead of using the original standard deviation for like, for this calculator,
Oh,
we
so
have,
I got the z-score. That's what I was reading off.
Oh, okay.
oh, yeah,
And then you take the
1.85.
z-score and throw it in.
Yeah, then
Yeah.
you just plug it into the applet and you're should be good to go.
Okay, let me make a note on that.
Did you figure out how to get the applet on Excel yet?
No, I'm so actually on this last like test thing, there's an applet link that's just to the applet, and I'm pretty sure I can punch out that and throw it into the Excel sheet.
Oh, that's a good idea.
Yeah. I just bookmarked the applet, so that would be nice if I can just throw it in there in the Excel spreadsheet.
1.8539. 1.8539. And we want everything below it
Above.
or above it. I mean, because it's okay. 0.319, so 0.32.
That'd be 0.032.
Yeah.
0, 3, 2. Yeah.
Okay, ready?
Fun.
4%. Oh. Really?
What did we get?
Well, that's not right.
None of these is correct?
Yeah, that can't be right. Because I know that's the variance. That has to be.
Why would they ask a question that none was correct?
What quantity is equal to the sum of the numbers in the square deviation? That's the variance.
Yeah, I agree.
It must be keyed wrong.
Yeah, maybe so.
Standard deviation so
What did you guys have for 15?
1.229.
Yeah.
That's what I had too.
Well, I don't know about 15, but 14, that can't be right. That's messed up.
Yeah, I think we're right on 14. Look.
15, the standard deviation of these temperatures. So we're talking about these guys. I still have that. I mean, I did that in Excel. There's no way I got that wrong.
15?
Yeah. 1.239.
Let me see your Excel sheet real quick.
Yeah, 1.239. That's right there. Yeah, so here's the data. Unless I entered in the data wrong, which I don't think I did. 37.91, 37.
We go
So
standard
then
deviation.
I said this minus the mean, this minus the mean equals that, this minus the mean equals that, and then same right here. And then I just squared those numbers, added them up, and square rooted it.
So you add the squares of those numbers,
So
and you have
get
to
the variance.
times them by, and then, okay, that equals the variance. And then you gotta square root the variance.
Oh, wait a minute.
You
Wait a
squared,
minute.
I just put it in the quantitative description statistics spreadsheet. Came up with a different number. Wonder what we did wrong here.
I'm missing something in there. Isn't there? It's like something minus the mean, or like the sample size goes in there somewhere in that equation, doesn't it?
well, the only thing I can think of is that yeah, I don't know. I'm looking at all my spreadsheets, trying to figure out.
Dang it. Why are you doing this to me?
So if you do the value time or minus the mean,
Can you give me the numbers for
square
this?
that, and then times it by P of probability. No, that's probability variance.
Does someone want to read off those numbers for me, please?
Oh yeah, sure.
Just
Hold on.
a second.
Sorry, it's coming. All right. 37.91, 37.25, 38.98, 38.16.
That I got 0.715.
Yeah, I just stuck it in there too, and that's the same number I got.
And yeah, I know there's some part of the equation that I'm missing. I know, like, you add up the sum of these numbers, and that's the variance, but then you do something with the sample size. I just
Let's
forgot
see if
what
I
it
can
was.
find the Hold on one second. Let me see if I can find that equation for that. Quantitative
Are you
data.
kidding me? Excel spreadsheet. Oh my gosh. I could have just said this equals standard deviation of these freaking numbers. Ah, that's dumb. I went through all that math.
Question. Where did you guys get that spreadsheet from?
The quantitative data one.
Yeah.
It is. I think it's on lesson. Hold on.
It's like lesson 1 or 2 or something.
Yeah,
Yeah,
it's a link attached to one of those first 3.
that's like in the reading, you find the link and it's like, here, follow this link to download the descriptive
Okay.
blah, blah, blah.
So it is on. Let's see, where am I?
Lesson 2,
Lesson 2. Oh no, I'm sorry, lesson 3.
3.
Yep. And it's
Quantitative, descriptive. Okay, there it is.
there you go.
And then statistics. I probably have downloaded this once already.
Well, shoot. Sorry, guys.
No, that's okay.
Check out the class statistics. Oh, man. Rest of the class got 100. Wait, so, is that right? Number 14, that's right? None of these? Doesn't make any sense.
So maybe it
Well-
has to do with the way we calculated standard deviation.
Yeah. Whatever. I don't care at this point. I'm gonna figure it out. So, I'm fine with not knowing right now.
All right. Well,
You recorded, right?
I did.
Nice.
All right. So I'll send you guys the link. Good luck on the test.
Yeah, thanks.
Thanks.
I'll see you guys. Have a good night.
Yeah.
Yeah.
Later.
Signing off.